Hey everybody, Jason here. So I've been struggling with this problem that I mentioned in my last video. As you can see, movement is still very blocky. In the game, it is just super smooth. And so this is something that I've been really wanting to achieve. And even though it's a very minor feature, I mean, you could certainly play this game as is and probably have a perfectly fine experience. It's just something that's been bothering me tremendously. So this is why there's not a ton of progress so far in this video because I've been focused almost exclusively on this problem since the last video. Now, I've actually just scrapped tons of code. I had actually achieved this perfectly smooth background scrolling, but it totally killed my collision detection. So right now I'm a little bit at a loss. I'm kind of searching for solutions as to how to solve this. So let me explain kind of what I've done and how I actually achieved smooth scrolling, even though you're not seeing it right now. So the issue truly is that when I move up and down and left and right, etc., that I am simply scrolling the background image 16 pixels, whichever direction you're going. So from one frame to another, um, the entire image will jump 16 pixels. So this is what's contributing to the blockiness effect, and this is the thing that the game does totally differently. Let me see if I can just open up the game really quick here. I'll just play it really quickly and show you. Um, Let me just mute the sound here. So you'll notice here when I'm playing the game, uh, the background just moves really, really smoothly. Um, and I was trying to replicate this the best that I could. And you'll notice a lot of other simple behaviors. Like I know you can't see how I'm typing here, but so if I move the character just a little bit and then I let go of the button, um, the character will actually continue moving and sort of snap into place. It'll sort of snap into the next sort of 16 by 16 pixel grid. And this is something that's important, I think, and here's why. Um, so my collision detection, the way that I've done it, if you're looking at that JSON file, is that each one of these mountains right now, and soon to be other entities, are kind of just mapped like I map the top left corner um, of the entity. And now I know, okay, when my character's top left corner is 16 pixels away from this mountain's top left corner, that I can't move forward, right? And so that's essentially how I'm doing it. I'm not really mapping every single pixel. I'm sort of keeping track of my top left corner and the top left corner of the thing in front of me or to the side of me, um, or wherever. And that's how I've achieved collision detection, and that works perfectly fine, assuming that you move exactly 16 pixels by 16 pixels. And so back to my solutions and that I've scrapped. So instead of me sort of just scrolling the background image 16 pixels by 16 pixels, what I did was take a totally different route for movement. I implemented velocity into the character's movement. So I gave the character a velocity, and I believe I chose like 0.25 or something like this for the velocity. Um, I got it to a point where it felt fairly similar to the game. And all this velocity means is, okay, frame by frame, the direction that I'm moving, how far should I move forward, right? Or how far should I move in that direction from one frame to another? And so this is where the velocity comes into play. So what I did is I know what direction the character is facing. Okay, so up, down, left, right, etc. And I know if you're pressing down one of the keys to move you in that direction, and then I have a velocity. Okay, so now each tick method, or each call of the tick method, I just increment the character's position by the velocity. And so in doing that, I was able to perfectly achieve that really super nice, super smooth background transition. And I kind of wish I hadn't uh, deleted the code so I could show you. But I mean, I worked on it for hours, and I just basically rage quit and just did a git reset. Um, the problem that I was hitting, that maybe some of you could predict, is that I would move around and everything would be super smooth, but then I'd walk right over the mountains. None of my collision detection worked. Um, and the reason for that is, again, going back to that top left corner thing. Okay, when I'm moving around at pixel level and I'm manipulating the user's position by, by pixel, I'm not always going to be perfectly within that 16 by 16 grid that I had mapped out for collision detection. Um, and I don't know. I'm wondering if the developers for Dragon Warrior 4 had run into the same problem, because simply because when the characters are moving around and then you let go of the button, they kind of continue moving to the next tile if you've sort of hit a certain threshold. So it's always snapping the user into place. Now I tried writing some code to achieve this, and I just wasn't getting it. So at this point, I'm kind of like, I'm taking a little bit of a step back, and I'm trying to see if I can approach this problem in a little bit of a different way. Now, one of the things that I've decided to try to do, to experiment with, is this thing here. So let me just pan over to the screen. This is an open source program called Tiled. Now, I said that I didn't want to use game engines, and I do still want to stick to that, and I am. But I thought that I would sort of take a sidestep and see what I can achieve by using Tiled. Now, my understanding of Tiled, from having used it for, I don't know, maybe an hour or two, is that I can map out a sort of a 2D world. And this does have some nice features, which I know nothing about yet, where I can sort of give some properties to these individual tiles. So my thoughts were, okay, these mountains are impervious to a player, but they might be traversable by a balloon or an airship. This water here, it's impervious to a player, but it can be traversable by a boat or by an airship, etc. So I might be able to embed some of that information into the tiles. And in doing this, and in working with this TMX file format, which is a very widely used file format for 2D tiled things, I might be able to achieve, or easier achieve, this collision detection that I'm looking to implement. So I'm experimenting with that. Going off into a deviation here, in experimenting with this, so this is going to take me a ton of time here. I've just done, or started to do, this one sort of top left chunk of the world, the overworld, and this is what I was originally working with. This over here is, this area is a tile set. And again, I found this thing online, and it seemed to be relatively complete. Maybe it is, but I was noticing a lot of like missing tiles, and there are things up here like that I don't think I've ever seen in the game. So I think that this is incomplete, or it's just from a different game or something. This just isn't right. And I had this like huge image for the overworld, which I'm using to actually render the game here. It's this 4096 by 4096 pixel image, and it has every single tile that I need for the overworld. Um, and so I was looking for a program that would sort of like generate it would generate a unique tile set from an image. And it doesn't seem like Tile does that for me. So I wrote a program that did that. And this is what you're seeing here. So I can show you a quick little example, and you can sort of see what it generates. Now this is takes a very long time for this thing to actually generate. I spent a lot of time today working with different sort of PNG processing libs, and I wasn't getting the results that I wanted. I started off working with this Python library to parse PNG files and to actually like be able to go through the chunks and stuff, and I was just having trouble with the documentation, sort of figuring out how I would be able to access pixel data at a given XY coordinate. Um, so I ended up just taking a step back, and I did it in JavaScript using Canvas because I'm familiar with Canvas. And so the idea being that I write the overworld file um, to a canvas, so it's huge canvas, 4096 by 4096, and then I go through and I step through 16 by 16, and I actually extract that image data, and then I create a unique hash map key for it, and I store that data in that key, and so that's a quick and easy way of sort of just taking out the unique tiles, right? And so what we're left with here is 77 unique tiles that it was able to find out of that whole overworld image. So if I've written this correctly, then from all of these 77 tiles, I'll be able to generate the entire overworld. My next step, which I haven't gotten into yet, is probably, since I don't want to go through and do this, is for me to actually figure out how this TMX file format works, and then actually go through the overworld and replace each and every tile, and actually maybe create a TMX file that I can kind of work with. But anyways, that's where we're at right now, and I guess I'll show you the program really quickly. Again, I guess this doesn't have very much to do with the game development, but for some it might be a little bit interesting. So I'll walk you through this. This is very procedural. This is not like well-written, well-tested code at all. This is just something I wrote to get this thing done quickly and move on. But let me walk you through it. So start off with the HTML file. I just have two canvas elements, and then I'm including my app script. Now this source canvas element, this is going to hold the source image, which is the overworld large image. The destination, this is going to hold the tile map that I generate. So let me walk you through how this works. So I grab a context from both canvas elements, and then I create an image element, just like a normal IMG element, HTML. And I give the source of the overworld image. And now when this image actually loads, when the browser downloads it and interprets it, this is when I start to work with the data. So the very first thing that you do is you set the canvas height and width to the size of the image so that everything lines up properly, and the browser scales. And then, excuse me, and then what I do is I go through 16 by 16 and I grab chunks of data from this canvas. So this is the important part here. This is very simple. I just, for each XY coordinate, so we start off at 0, 0, and then I grab the image data from this. So now I'm grabbing 0, 0, and 16 wide by 16 high, and I'm storing that data here in this variable. This is a strange type that I had never heard of before. It's a type of, it's actually called a typed array in JavaScript. I had no idea that this thing existed. But in a typical array, you can just do a join method. You could just do, img data.join, right? With a comma, for instance. And it'll sort of take all of the, it'll take everything within that array and it'll just append it to a string with a comma in between. I wasn't actually able to do that with this type of array. So I kind of had to do my own join method here, basically, and this is what you're seeing right here. This is a really naive, inefficient way of me creating a hash map for this stuff. So this get image data, basically each instance or each index of this array represents one pixel. And so you have all the pixel data that you need within there. So you know what color it is, etc. So this hash map represents all of the uniqueness of the image. And so then I just store that here in unique tiles, which is just a normal object. And if that key already exists, it's just going to overwrite it. And so what we're left with then is just the unique ones. So now that we have gone through the entire image, and this takes a while because it's very inefficient and this is a large image, then we just come down to here and we figure out how many unique tiles there are. And then we just sort of try to put everything in, stacking up on top of one another. So we figure out how many tiles per row we can have, and then we set the canvas height and width, and then we just loop through those unique tiles and print them off into the canvas. Now we actually hide both of the canvases, so you're not going to see them. And then I just create an image, an actual PNG file, based on the second canvas's data. And then I append that to the DOM, and this is what you see. And now I'm able to actually take this and download it. And that's exactly what I've done. And now I pulled that into here, the same image. And now I can use this data. And this is kind of the cool thing that I'm noticing, is that when I first used the tile set from here, I wasn't getting the kind of like, you know, ocean borders, right, that you want to see. So with my tile set, I can come along here, and first of all, it looks more vibrant. These colors are deeper to me. And so now I can actually have this like ocean border, and I have one for each one of these guys. So there's one of these, which is good. So now I just feel like I'm going to get better details when I come to this. And what I'm hoping for, again, is that with this TMX file format, that there will come that I'll be able to implement collision detection in a more sane way, where I can also have smooth background scrolling. So that's it for now. I'll try to give you guys a progress update soon. Sorry for the kind of lack of progress, but I've been really obsessing with this problem here. And if anybody has any feedback, any ideas, I would really love to hear it. So thanks for watching, and talk to you guys soon.